All right, here we go. 10.5. Probably my favorite section because it's angles related to a circle. So now we're going to get all these important theorems that relate angles to their arcs. So the first thing we're going to do is we're going to focus on angles whose vertex is inside the circle. So for this first one, which we kind of already talked about, is a central angle. And a central angle is formed by two radii. So I'm going to draw two radii in the circle first. So we have two radii here, AC and CB, and they are forming this angle right here, which I'm going to just label with X. So a central angle is always going to be equal to the measure of its intercepted arc. So in this case, AB is the intercepted arc, and if that is X, so is that. So your general rule is going to be the measure of your central angle, in this case ACB, is equal to the measure of the intercepted arc. The next type of angle we're going to talk about, whose vertex is also located inside the circle, is a chord-chord angle. And a chord-chord angle is formed by two intersecting chords. So I'm going to draw two chords in the circle. So we've got chord AC and chord BD, and they intersect at point P. So the angle I'm referring to could be one like here. Okay, so I'm going to label that with X. Notice that the vertex is not at the center. It could be really anywhere in the circle. So the relationship between that angle and its intercepted arcs, okay, so we've got CD and we've got BA over here. So Theorem 87 in your textbook says that when you're finding a chord-chord angle, the measure of that angle, in this case angle CPD, is equal to half the sum of the two intercepted arcs. So those would be the measure of arc CD plus the measure of arc AB in this case. So what I used to tell my students last year to remember this was it looks like it's kind of forming a plus sign. So there's your hint. When you are trying to find a chord-chord angle, you want to do half of the sum of the two intercepted arcs. So that was two cases where the vertex was inside the circle. Now we're going to focus on those cases where the vertex is on the circle. So the first one we already know, again, it's an inscribed angle. And an inscribed angle is formed by two chords. So I'm going to draw in those two chords. We've got AB and BC. The angle that I'm referring to, here is its vertex. Its vertex is at B, and I'm going to label the actual angle with X. So we know this already, but now as a theorem, Theorem 86 in our textbook, we know that the measure of an inscribed angle, in this case angle ABC, is equal to half the measure of its intercepted arc, in this case AC. Another way you could think about it, if this is X, we know that AC is double that. So you could think about it as half or double, depending on which way you're going. Another type of angle whose vertex is on the circle is a tangent chord angle. So remember, a tangent touches a circle in one point. So I'm going to draw that angle for you. So we've got chord DB and tangent BG, and the angle formed by them, here's the vertex on the circle. Here's my X, which is my angle. And Theorem 86 also talks about how when you have a tangent chord angle, the measure of that angle, in this case, which would be DBG, is equal to half of its intercepted arc. So in that case, the intercepted arc would be this whole thing, so arc DB. So if that's X, the whole arc would be 2X. The last three types of angles, it's great because they all have the exact same formula. So any angle whose vertex is outside the circle is going to have one specific formula. First one we're going to talk about is a secant angle. So I'm going to draw two secants. I've got secant PC and I've got secant PD. Notice that the angle is outside the circle as well as the vertex P. So here is my angle. And now, just like our chord angle, we took half of something to do with the intercepted arcs. We're going to do the same thing here, except we're not going to add the intercepted arcs. We're going to subtract the intercepted arcs. So Theorem 88 says if we want to find the measure of that angle formed by the two secants, in this case angle P, we're going to take half of the difference of the intercepted arcs. So that would be arc CD minus arc AB. Really need my whiteout today. Okay, so, and just to kind of simplify that a little bit, because you may be saying, well, how do I know which one to put first? Because, well, if I put AB first, I'm going to get a negative angle. So in this case, the way you can always think about it is you're taking half the major arc minus the minor arc. So I used to say all the time to my students, major minus minor. Okay? So just if you want to write out Theorem 88, the secant angle measure is half the difference of the intercepted arcs. But that's going to apply to our secant tangent angle as well. So I've got my secant, PC, and I've got my tangent, PB. B is the point of tangency. I know that the angle outside is going to be right here. So again, Theorem 88 says that the measure of angle P in this case should be equal to half of the major arc. In this case, the major arc is CB minus the minor arc, which is AB. And then for the last one, again, here are my two tangents, PA and PB. Theorem 88 says that I should take the measure of angle P, and that should equal 1/2 my major arc. So in this case, my major arc is going to go all the way around. So that's why I put point E, because remember, when you name a major arc, you need that third letter. So arc AEB minus my minor arc, which would be AB. And just something to notice, that the two intercepted arcs here make up a full circle. So that's 360 degrees with the major and the minor. Okay, so those are the different types of angles related to a circle. So we've got vertex who's inside, vertex on, and vertex outside the circle. So now you're going to try some practice problems with all of these different theorems. So here are your first three examples. I'm going to leave you to do all three of them on your own first and submit your answers, and then I'll take you through each one step by step. So for the first one, you have an inscribed angle. You know that an inscribed angle is half of its intercepted arc, so that's why I set 70 equal to half of 141x minus 1. And then after that, it's just simplifying. So multiply both sides by 2 to get rid of the half, move things around, and you should have gotten x equals 1. For number 2, you've got two chords. You've got the chord angle 124 degrees. Remember, I said it kind of looks like a plus sign, so the measure of RPQ is half the measure of the sum of the two intercepted arcs. So the intercepted arcs would be RQ and SC. So I multiply by 2 again to get rid of that half, combine my like terms, and you should get x equals 6. And for the last one, you have a tangent. So here's my tangent. My point of tangency is L. And you've got a chord, KL. So a tangent chord is just like an inscribed angle. It's half the measure of its intercepted arc. So half of 130 degrees gives us 65 degrees for KLM. Here are your next and last three practice problems. So I'll give you time to submit your answers, and then I will go through each one. So in number 4, we have two secants, and we've got this secant angle formed outside the circle. For secant angles and tangent angles, which we have in number 5, and secant tangent angles, which we have in number 6, remember it's 1/2 major minus minor. So here, 5x minus 10 equals 1/2 my major arc minus the 60 degrees, my minor arc. And that's how you end up getting that RB is 150 degrees. You should get x is 11 and plug it back in. For number 5, we know that if this is 120 degrees and there are 360 degrees total around the circle, that leaves 240 degrees left for the major arc. So that's why I put this little point A in so that I could name it. So angle Q is equal to 1/2 major minus minor, and you end up getting that angle Q is 60 degrees. And last but not least, angle E out here is formed by a secant and a tangent. It's 1/2 the major, which is 6x plus 14x, minus the minor, which is 58 degrees. Again, you got to move things around, solve all the algebra here. You get x is 8, but to find the measure of angle DEG, you have to plug it back into your expression, and you should get 30 degrees. So if you need me to go through any more of these, just let me know, and I can take time in our next classroom session to talk about them.